Hi guys. Let me start by asking you something. You have a question, something you want to know about the world. Maybe you want to know whether a new therapy helps depression, or whether social media actually damages teenagers' mental health, or whether intelligence is hereditary. You've got the question, so now what? Most people think the answer is simple. You get some data, you run some statistics, you publish, done. But that's like saying the answer to how do I write a novel is put words on paper, right? It's not wrong. It's just that it misses everything important. So between your question and your answer lies an entire structure of choices. Every choice shapes what you can discover. Every choice carries ethical weight, and most researchers never stop to think about this. So today we're going to walk through the research cycle, the complete journey from question to conclusion, and I want you to understand not just what researchers do, but why they do it, and what can go wrong when they don't think carefully. So the research process isn't a random collection of steps. It's a cycle, a structured sequence that moves from question to answer and ideally to new questions. So there are major stages. The first one is you formulate a research question. Then you write the hypotheses. Then you design the study, which we'll talk a lot about choosing the variable, the sample, the type of study. Then you have to recruit participants, which can be difficult and is much more complicated than you realize. Then you collect the data, which is actually the easy part, analyze the data, and then interpret the findings and share your results. So this is the basic structure, but I want to be clear about something. This structure exists because researchers have learned, sometimes painfully, what works and what doesn't. So each step serves a purpose. Each step is a test of rigor, if you will. And if you skip a step or do it carelessly, the entire enterprise is compromised. So let's walk through each one, and as we do, I want you to think about what moral problems can arise at each stage, because like I've said before, and I'll say many times, research is a moral issue. Research is an ethical issue. So everything begins with a question, not a vague interest, not a hunch, a specific answerable question. And this matters more than you might think. So a good research question is specific, not does therapy help, but does cognitive behavioral therapy reduce depressive symptoms in adults with major depressive disorder? Okay, a good research question also has to be answerable. You can collect data that addresses it. Okay, you can actually collect data in order to answer this. It has to be interesting, believe it or not. Okay, it has to connect to theories, to practice, to real human concerns. Otherwise, why are you doing it? And then again, it has to be ethical. It won't harm people, or at least it won't harm people too much, okay? So now here's something that is subtle but also important. Your research question doesn't come out of nowhere. It emerges from theory and from prior research. So you're not making something up. You're asking, given what we currently know, what don't we know? And what can we figure out? Okay, so this matters because it means you need to know the literature. You need to have read what others have done, and you need to position your work within kind of a scientific conversation that's been ongoing, sometimes for millennia. If you don't, you might waste time asking questions that have already been answered, or you might ask questions in a way that misses what scientists have already known and done about how to ask them. So researchers sometimes start with a desired answer, not a genuine question. So I believe meditation is beneficial. What evidence can I find to support that? That is not a research question. That's bias pretending to be scientific inquiry. A research question is, I don't know whether meditation changes anxiety. Let me design a study to find out. Okay, I'll treat what we call the null hypothesis, or the opposite hypothesis, that what you want to find out is wrong. I'll treat that seriously. If meditation doesn't help, I'm going to report that. The difference seems small, but it's not. It's the difference between integrity and intellectual dishonesty. Okay, so that's the ethical concern of stage one. Now, stage two is writing the hypotheses. So once you've got a question, you translate it into a hypothesis or hypotheses, multiple ones. So a hypothesis is a specific testable prediction about relationships between certain variables. And there's two types, the null hypothesis and the alternative hypothesis. So the null hypothesis states that there is no difference or no relationship between the variables you're studying. So some examples. There's no difference between depression scores between people who receive like cognitive behavioral therapy and people who receive like Gestalt therapy or something like that. So there's no difference. Okay. Remember, null hypothesis states there's no difference or no relationship between the variables. Another example, intelligence and income are not related. Okay. Social media use is not related to anxiety in adolescence. The null hypothesis assumes that nothing interesting is happening. It's the baseline. There's no difference. There's no effect. It's what we expect if there's just, random variation, but no real effect. And this is very important to statistics. We'll talk about this later on. So just sort of get it in your mind that we have a null hypothesis that says there's no difference or relationship between variables. And then we have an alternative hypothesis that states that there is a difference or relationship. The alternative hypothesis is what we hope for when we do a study. Okay, so some examples of that would be a certain type of therapy reduces depression more than standard care, whereas the null would be that it doesn't reduce depression. Okay, intelligence and income are related. They're positively correlated or whatever. Increased social media use is associated with increased anxiety. So notice the difference. The alternative hypothesis makes a specific prediction. It says what relationship you expect to find and that there is a relationship, whereas the null hypothesis says, no, there's no relationship. So null is like no, and that's dull. Null. Okay, that's the way I always remembered it when I took these classes. So here's why this matters. If you don't specify your hypothesis before you collect data, you open the door to what's called p-hacking and other forms of intellectual dishonesty. The p-hacking, we'll talk about this more later, but you fish through your data looking for significance, looking for patterns, and then claim that you predicted them all along. And this is a major problem in psychology. Many studies haven't pre-registered their hypotheses, published ahead of time what their hypotheses are going to be. So researchers look at data, they find something interesting, and then they write it up as if they predicted it. And this is a moral failure. This is corrupted science. Okay. And the reason why is because if we are fishing for significance, if we're fishing for something we can publish, something we can tell the world that we found, then we often manipulate the data in order to prove that, in order to show that. But if we say what we're looking for ahead of time, what we call pre-registration, which is publishing your hypotheses and your study design before you collect the data, now you have a record of it. You can't change your story later. It keeps you ethical. It keeps you from manipulating data in order to get some result. Okay. And the reason why people do that is because a lot of researchers' jobs depend on it. So like at a university, not so much at a community college, but at a university, there's what we call publish or perish. So you either publish research or you lose your job. You probably lose grant funding and then eventually you lose your job if you're not publishing. And so these researchers are often desperate to get something published, and journals will only publish positive findings. They won't publish that you found nothing because that's boring. That's no and dull. Okay, that's the null. They don't like publishing that. So it motivates researchers to be dishonest, which is a big problem in all of science, not just psychology, all of science. So as a researcher, your ethical obligation is to specify what you're looking for before you look so that you don't end up going fishing for significance, p-hacking. Okay, I'll explain that term more later, but I'm sure you get the idea. Okay, so stage 3. Stage 3 is you define your variables. What are you manipulating? What are you measuring? Now you need to translate your hypothesis into concrete variables. So we have an independent and a dependent variable. The independent variable is what you manipulate or compare. It's the presumed cause. It's the variable that you think is going to influence the outcome. Independent influences, okay, if that helps. In an experiment on therapy and depression, let's go with that example. Let's say the independent variable is the type of therapy. This is what you think is going to influence the outcome. Okay, so cognitive behavioral, Gestalt, marital and family therapy, systems theory, whatever. Okay, there's all sorts of types of therapy, but that would be the independent or the influencing variable. Okay, it's called independent because you, the researcher, control it. You decide who gets which therapy. You decide independently of anything else. Okay, the dependent variable is what you measure. It's the hoped for, the presumed effect. It's what you believe is going to change as a result of the independent variable. So in the therapy study, the dependent variable is the depression score, measured like on a standardized depression inventory. So the dependent variable is called dependent because its value depends on the independent variable. Your amount of depression depends on the type of therapy you get, on the independent or the influencing variable. Okay, the outcome depends on the cause. So here's why this distinction matters. Only when you manipulate the independent variable can you establish causation. If you're just observing variables without manipulating them, you have a correlational study. You can see that variables are related, but you can't tell which way the causation goes or whether both are caused by something else entirely. So for example, do intelligent people earn more money because intelligence causes higher income? Or do wealthy people afford better education, which makes them seem more intelligent? Or does something else, maybe family background, cause both high intelligence and high income? Correlation alone can't answer these questions. Only experimental manipulation can. So you would have to take a child and maybe you take a set of twins from their mom and you put one into a high income family and one into a low income family, and then you look to see what happens to them. Okay, you're manipulating the variable, but that's often unethical, so we're generally left with correlational research. Okay, so operational definitions. Now this is more important than it seems. You have your hypothesis, you've identified your variables, now you need to operationalize them, and we're going to talk more about this in the next lecture, so we're just going to quickly go through this. So an operational definition describes your variable in terms of the specific procedures you use to measure or manipulate. That's abstract, so let's make it concrete. So suppose your hypothesis is intelligence and academic success are correlated. They're positively correlated. As one goes up, the other goes up. So you have to ask, what is intelligence? What is academic success? These are abstract concepts. You need concrete, measurable definitions. So you might define intelligence as a score on the Wechsler, the IQ test. And academic success might be your cumulative GPA at the end of your first year. Now your hypothesis is testable. Now you can collect information, the data for your study, okay? But notice something crucial. Your operational definitions contain assumptions about what these constructs really are. By defining intelligence as a Wechsler score, an IQ score, you're saying intelligence is what the Wechsler measures, but is it really? By defining success as academic success as GPA, you're saying academic success is grade performance, but grades are often determined by like how well you conform to the teacher's expectations, how much you study for the test. Does that truly measure learning? Does it measure mastery? Does it measure growth? Okay, so the point is your operational definitions shape what you can discover. Okay, and different operationalizations might lead to different conclusions. So we're going to talk about that more in the other lectures. So I'm not going to harp on it too much, especially because my throat is sore today. Probably because I just got finished teaching another long class. Okay, but stage 4, sampling. Okay, this seems like the simplest part of a research study, but it is indeed not. So who is your study about? You can't study everyone. You need to select a sample, a subset of people from the larger population you want to understand. We'll also talk about this more in the other lecture. So the fundamental question, is your sample representative of your population? If it is, you can generalize your findings. If it isn't, your conclusions only apply to the particular group you've studied. So there's different ways of taking samples. The best way is random sampling, meaning that every person in the population has an equal chance of being selected for your study. So some ways to do this is you get a list of all the people in your population. You use a random number generator, okay? Or maybe draw names from a hat, and then you contact everyone selected until you get your desired sample size, okay? So that would be the best way to do it. Or the best way to pick a sample is through random sampling. Random sampling has a huge advantage. It minimizes sampling bias. So over many samples, random selection will produce groups that are very similar to the population, okay? Random sampling doesn't guarantee that it's a representative sample. It just makes it less likely. It makes bias less likely. Okay, so we want our sample to represent our overall population as much as possible. So if you randomly select from the population, then you're much more likely to get that. But if you randomly select from a biased population, you get a biased sample. If you randomly select people, and some refuse to participate, the ones who refuse might be different in systematic ways than those who accept. So for instance, if you were doing a study on sexuality and you try to randomly sample things, there's going to be a lot of people who are maybe embarrassed about sex or just very conservative and modest, and they're not going to want to participate in the study. So now you have a biased sample. Even though they were randomly selected, they still end up biased. A more sophisticated approach is stratified random sampling. So you divide your population into subgroups or strata, okay? Strata are levels. And these subgroups, the strata you choose in whatever way that matters for your question, maybe gender, age, socioeconomic status, depends on what you're testing. Then you randomly sample from each stratum to ensure that your sample reflects the proportions in the population. So however many women are in your population, however many 30-year-olds are in your population, whatever. You try to get it as proportional as possible. This helps to ensure representativeness, at least on known dimensions, but it can't account for everything. Can't account for unknown dimensions that where your sample might differ. So there's always going to be some bias, but we'll talk about how we account for that statistically later on, what we call variability and noise. Those are all terms that we are going to get to know very fondly throughout this class, okay? Now, not all studies use random sampling. Sometimes you can't. Sometimes you don't want to. Sometimes it's too expensive. So convenient sampling means that you recruit whoever is easily available. Students in your psychology class, people at the mall, friends of your friends. It's fast and it's cheap. But the disadvantage is your sample is probably not going to be representative. Psychology students are younger, more educated, more weird, Western educated, industrialized, rich, democratic than the general population, okay? So sometimes it works, but it's problematic. Snowball sampling is another convenience way of choosing, not convenience, another non-random sampling method, okay? So there's non-random sampling method is the umbrella, then you have convenient sampling, you have snowball sampling, and then we're going to talk about purposive sampling next. So snowball sampling means that the early participants in the study refer other participants. So you ask, do you know anyone else like you who might want to participate? Okay, so for instance, we did a study on autism, and when we found a few people, we asked, do you know anybody else who has a child with autism? And then they referred, so that was snowball sampling. So that's useful for hard to reach populations like parents of autistic kids, people with rare conditions, homeless people engaging in behaviors that might have a stigma attached to it. The disadvantage is it's very severe selection bias. So people tend to refer others who are like themselves, so your sample becomes increasingly homogeneous or increasingly similar. Okay? Now, purposive sampling means that you deliberately select people based on characteristics that are relevant to your study. You have a purpose to who you pick. So you want to study factors that predict treatment success in depression. You might deliberately sample people with varying symptom severity, with different treatment duration, different demographic backgrounds to ensure that you capture, diverse experiences. So the advantage of this is that you can ensure that your sample includes relevant variation, the variation that you want to see. The disadvantage is you're making judgments about what's relevant, and that introduces bias. So pros and cons to everything. So here's the ethical principle with this. You have to be honest about your sampling method and its limitations. If you use convenient sampling, say so. Don't claim your findings apply to all humans. They apply to your particular convenient sample. You need to acknowledge that. Many psychology studies are conducted on college students here in America. So researchers then generalize to all humans. And that's intellectually dishonest. Okay, they need to say that it may not generalize. You can generalize to the population that your sample represents. If your sample is college students, you can generalize to college students. If you want to generalize to humans, broadly, you need a sample that represents humans in a broad way. Now you need to decide how will you collect your data? What kind of study are you doing? There are three major types, and they differ in what they can tell you. So we have descriptive studies, correlational studies, and experimental studies. So let's start with descriptive studies. So a descriptive study aims to describe a situation. It answers, what is this like? What are its characteristics? It describes it. So some examples, what percentage of college students report depression symptoms? That's descriptive. How many hours per day do teenagers spend on social media? You're describing something. What are the lived experiences of people with PTSD? What's it like to be them? That's descriptive. What descriptive studies cannot do is determine causation, what's causing it. You can describe that depression is common. You can describe what a person's life is like who has depression, but you can't determine what causes it. The advantage is it's relatively simple to conduct. It helps us to understand the issue better. But the limitation is it's limited to answering why questions. A correlational study examines the relationships between variables. It answers, are these variables related? Do they move together? Okay. Some examples, is social media use related to depression in adolescence? Is there a correlation? If social media use goes up, does depression go up? Or down, does it go down? Opposites. Do people with higher exercise levels have lower anxiety? Is there a correlation? Is income related to educational attainment? Correlational. So you measure both variables, income and educational attainment, and then you can calculate a correlation between the two. If the correlation is strong and positive, the variables are moving together. As one increases, the other tends to increase. If the correlation is negative, they move opposite. As one increases, the other decreases. Okay, so positive correlation is they could both go up or they could both go down. Negative means they move opposite ways, okay? So keep that in mind. Hopefully you learned that in earlier psych classes. So correlational studies cannot determine causation. You can know that social media and depression are correlated, but you can't know which way the causation goes or if there's causation at all. They could be being caused by something else entirely. This is one of the most misunderstood points in science. Media headlines will read like, social media causes depression based on correlational findings. No. The correlation means they're related. It does not mean causation. Maybe social media causes depression. I theorize that it does. That's my hypothesis. Maybe depression, though, causes increased social media use because depressed people seek connection. Maybe both are being caused by loneliness or social anxiety, and there's really no true causal relationship between them at all. Maybe depression and social media use are both, caused by poor sleep. Correlation doesn't tell us, okay? The advantage is it can detect relationships, which is very important. And it's, they're also more practical to conduct, cheaper to conduct, easier to conduct than experimental research. Sometimes they're the only type of study that's legal to conduct, depending on what you're studying. The limitation is, of course, that it can't determine causation. Now, an experimental study, on the other hand, absolutely can. So an experimental study manipulates an independent variable to influence, and randomly assigns participants to conditions, control condition or experimental condition. So it can answer, does one variable cause a change in another? Not just are the variables related, but can it cause the other variable to change? So an example, randomly assigning people to receive therapy or not, and then measure depression after treatment and compare the groups. So you can see, is that therapy causing a change in depression? Randomly assigning people to receive like a sleep intervention, or placebo. So you measure to see if their mood changes. You measure mood and anxiety after receiving those interventions, and you can compare. That's experimental. Assigning people to like high versus low social media use conditions, or maybe to quit social media condition, and then measure their mood, measure their anxiety, and see if that changed it. Okay, so the key feature is random assignment. You decide who gets which condition. You do this randomly, not based on participant preference or any other factor. Okay, and of course, why does random assignment matter? Because it controls for confounds, it controls for variability, it controls for noise, it decreases variance or variability in the study, which is very important. You're going to be calculating that later on, so get comfortable with that idea. So what is a confound? A confound is a variable that is related to both your independent and dependent variables, and it creates an alternate explanation for your findings. It confounds it, it confuses it, okay? Imagine you study whether therapy helps depression, but you let people choose whether to enter therapy or not. So people who choose therapy might be more motivated. They might have more social support. They might have milder symptoms. If they improve more, is it because of therapy or because they were more likely to improve? That's a confounding variable. Therapy, in this case, was confounded with motivation, with support, with symptom severity. You can't separate the effect of therapy from these other factors. Random assignment solves this. So if you randomly assign people to therapy or control, then on average, the group should be equal on all variables: motivation, support, symptom severity, everything. So if the therapy group improves more, now you can attribute it to the therapy, not to the pre-existing difference. This is what we call the signal versus the noise. The signal is the truth that you're looking for. And noise is everything that all the confounding variables that can mess it up. Okay. This is why experiments can establish causation, but correlational studies can't. In an experiment, you control which people get which treatment. In a correlational study, people self-select into groups, and that self-selection introduces confounds. So the advantage of experimental studies is that it can determine causation, and it's the most powerful type of experiment for understanding mechanisms of causation. The limitation is it can often be artificial because you're sort of forcing things, can sometimes be unethical or even illegal. It requires random assignment, which isn't always easy to do, and it's not always practical, okay? And then experiments can also be more expensive because of that. Bias doesn't enter your study at one moment. This keeps researchers up at night, okay? It doesn't have a single source. Bias seeps in your study at every stage. So you start with assumptions about what's important, about what's real, about what matters. If you believe intelligence is fixed and hereditary, you'll design studies to demonstrate that it is hereditary, to demonstrate heritability. You'll notice evidence that supports genetics, and then you overlook evidence for the environment influencing it. So this isn't necessarily dishonest. I mean, it is, but it's human. We see what we're looking for. This is just how we all work. The solution to this is intellectual humility. You need to acknowledge your assumptions. You need to look for disconfirming evidence that contradicts what you're hoping to see. And you need to design your study to test whether you might be wrong. Now, you might frame your hypothesis to make a particular outcome more likely. This is bias in hypothesis formation. If you predict therapy will help some people, that's almost impossible to falsify. Of course, therapy helps some people. A better hypothesis is cognitive behavioral therapy will reduce depression scores by an average of 10 points on like a 63-point scale. Okay, it's specific, it's testable. Bad hypotheses are vague, which makes them hard to falsify. Researchers can always claim their hypothesis was confirmed if it's vague. Okay, that's bias in hypothesis formation. Now, in sampling, we talked about this a bit, but you might recruit participants in ways that favor a particular result. If you advertise for a depression study in a mental health clinic, you'll get people with more severe depression. If you advertise on social media, you might get like a younger, more tech-savvy group of people. Either way, your sample doesn't represent the general population. And if your recruitment method is related to your outcome of interest, that's especially problematic. So the solution is, of course, as always, random or at least hopefully representative sampling. If that's not possible, then you need to report in your study your actual sampling method and limitations. Now, with data collection, you might collect data in ways that favor your hypothesis as well. If you're measuring mood and you know someone received therapy, you might unconsciously ask more leading questions or interpret ambiguous responses more favorably. This is why blinding is important in experiments. So in a blind study, you don't tell the person measuring the outcome which group the participants are in. You usually don't tell the participant which group they're in if that's possible, like a placebo drug. Placebo therapy is obviously not. But, the person who is collecting the data, who's analyzing things, you wouldn't tell them which group the participant was in. That's called blinding. So this reduces the influence of expectation, okay? Or better yet, use objective measurements where you're not relying on human judgment. Now, in analysis, once you have data, you might analyze it in ways that favor your hypothesis. So you might try multiple analyses and report only the ones that are significant. This is p-hacking, which we'll talk about more later. You might exclude outliers because they contradict your prediction. A really bad example of this, or a really good example of this terrible thing being done, is the reason why we're so anti-fat in the modern world. There was a study done in the 1960s by a guy named Ancel Keys, I believe it's called the 7-country study, and he went around to different countries and collected data on heart attacks and fat intake, and he found the more fat these people in these countries ate, the more heart attacks they had. And so it completely revolutionized nutrition in the United States and the rest of the Western world, where we started cutting fat out of the diet, heart healthy and so on. But what we actually found out was that he selectively dropped countries from the studies who had low fat intake but high heart attacks, or high fat intake but low heart attacks. And what he truly found, if you looked at all of his data, was that there was no relationship between fat intake and heart attacks. And that's what he wanted to see. Okay. So So his analysis of the data was very biased in order to favor his hypothesis. And he didn't publish that he dropped these countries out of the study. That was the big issue. He wasn't honest about it. Okay. The solution to that is to pre-register your analysis plan, to be honest about what you drop out, what you keep, and so on. Okay. So in interpretation, at the final stage, you might interpret results in ways that support your hypothesis, especially if the results are ambiguous. So a correlation of, I know this may not make sense to you, but R is the letter we use for correlation. So an R of 0.15 is weak, but you might describe it as significant because of it. I don't want to confuse you guys, but let's say it has a significant P value. P is the probability value. We're going to talk more about that, okay? So it's significant, but it's very weak. So you might decrease the emphasis on it being weak and emphasize the significance of it, okay? You might focus on subgroups where your hypothesis was true, but you downplay others or don't mention it. You might discuss findings, in language that sort of overstates what your results actually show. All of this is bias. Some of it could be honest error, some of it's intellectual laziness, and some of it's deliberate dishonesty, okay? There was a study that was done very recently. It was done during the whole, when Black Lives Matter, there was the rioting and everything going on during COVID. And this study showed that Black babies born in the hospital where the mom has a white doctor are significantly more likely to die. And that was a shocking finding, right? Absolutely shocking. And so a lot of moms went out and they refused to have white doctors. Why would you want a white doctor if you knew that increased the chance of your baby dying? But what they found out was that they dropped all sorts of data that showed that there really was no difference between white and Black doctors. And if anything, the babies might have done a little bit better with white doctors than Black doctors, okay? And so you were sending all these women into situations where their stress was high, which is dangerous for the baby. They're stressed out about having to have a white doctor. Maybe they're driving longer distances to find Black doctors because they want to avoid the white ones. The Black ones at their local hospital get impacted because all the Black moms want to be with the Black doctor. And so there's cases where women were driving hours to find a Black doctor and avoid a white one, even though their baby was just as safe with a white doctor as with a Black doctor. And so the women were actually put into more danger because of this study, because of the bias that the people who did this study were part of the Black Lives Matter movement, and they had an anti-white bias. And so they changed the data. And what came out later was that they knowingly changed the data. There's actually memos where they talked about it. They didn't want the results to show that white doctors were okay. And so they purposely dropped it out. Okay. So sometimes it's deliberate dishonesty. And the only solution to this is integrity. You have to commit to reporting what you found, even if it contradicts your hypothesis, even if you hate it. Okay. Even if it's against everything you stand for. You have to report effect sizes, not just p-values. We'll talk about what that means. You have to acknowledge what limitations there are. You have to discuss alternative explanations. You have to be the kind of researcher who changes their mind when evidence demands it. Okay, that's how science works. That's how you build knowledge. Okay, so I've covered the technical aspects of research design. Now let me connect this to ethics, okay? Because every design choice has moral weight. If you use a biased sample, you misrepresent your findings. You're claiming something is true about humans when it's only true about your particular group. That's a lie by omission. If you don't pre-register your hypotheses, you enable p-hacking. You make it possible for yourself and others to sort of mine the data for significance. This corrupts the scientific record. If you ignore confounds, confounding third variables, you attribute causation where it may not exist. You might convince people that a treatment works when it doesn't. Something else is actually working. And then you might divert resources away from the real solutions. If you interpret results favorably to your hypothesis, you're prioritizing your ego over the truth. You put your need to be right above your responsibility to be honest. And this last one is such a big issue in our society right now. People don't care about the truth. They only care about what makes them feel good. They only care about their ego. The truth is the truth, whether you hate it or not, whether it makes you feel bad or not. It doesn't matter. The truth is the truth. And if you allow this crazy political nonsense to get into science, you're going to destroy science, okay? The truth has to be the truth, no matter how much you hate it, right? Research design is not just a technical exercise, it's moral practice. I harp on this over and over again because it's such a big deal in research. There's so much bad science going on because of this. How you design your study, who you pick for your study, how you analyze it, determines whether you're pursuing truth or you're just constructing a narrative, a story that feels true and makes you feel good. So let me summarize what we have covered, okay? Research begins with a specific answerable question that's grounded in theory, that's grounded in the literature of prior work. You translate your question into a null and an alternative hypothesis, okay? And they have to be specific predictions you can test. Then you identify your variables, the independent variable, the influencing variable, what you manipulate and change, and the dependent variable, what you measure. Then you operationalize your variables, define them concretely in terms of procedures. Okay, but remember, your operationalization may not perfectly capture the construct that you care about, so you have to keep that in mind. We'll talk more about that. You design a sampling strategy. Random sampling is best. It reduces bias. Non-random sampling is sometimes necessary, but you have to acknowledge the limitations when you write up your study. Then you choose a study type. So descriptive study, what is it like? A correlational study, are variables related? Or an experimental study, does one cause another? So you must design your study, whatever type of study you choose, to minimize bias at every stage, in the framing, in the hypothesizing, and sampling, collecting, analyzing, interpreting, okay? And throughout, you must treat research as a moral activity. Your choices shape what gets discovered. They shape what the public believes. They shape how resources get allocated. They shape government policies and laws. People live and die, go to prison, commit suicide, whatever, based on science. You have to take that seriously. All right, so we're going to dive into sampling. We'll talk about sampling distributions. We're going to get into central tendency. This is all foundational for everything that follows. Hypothesis testing, confidence intervals, all of it. Okay, so as you go through this week, I just want you to notice research claims. This new therapy is proven effective. Social media causes depression. This vitamin improves memory. Look beneath these claims. Ask, what was their sample? What was their design? What was their hypothesis? What did they use as operationalizations? Is it biased or limited in some way? Start thinking like a scientist who questions everything, including and especially your own beliefs and work. All right, see you next time.